Hello, sir. Hello, sir.
Hi,
Yeah.
yeah, you're
So,
started?
yeah. So we are starting now. I will just send the link also because we have just
Okay.
changed the link. We have just changed the link because of there was some previous there was some problem with the previous link. So we have just changed the link.
Okay.
Yeah. So in I will ping you here to start, sir. When to start, we'll ping you.
I'll
Here,
tell
sir.
you in the chats when to
Yeah.
start, sir.
Yeah. This new streaming link.
Okay. So I see a link for you.
Is that the one?
Yeah, that's the one, sir. That's the one, sir.
Okay. So what about the participants? We are already half an hour late and
We have already posted the new link in the existing video, sir. So let them, once they join, we get most of them join, then we will be starting the new video.
okay. So the link which you have given me in the chat is the new link, is it? New video link.
Yes, sir.
Okay. And that's going to go live, right?
Yes, sir.
And that's going to go live, right?
Yes, sir.
Good morning, everyone. On behalf of Don Bosco College of Engineering, Fatorda, Goa, India, we would welcome you all. On behalf of Don Bosco College of Engineering, Fatorda, Goa, India, we would welcome you all. On behalf of Don Bosco College of Engineering, Fatorda, Goa. Distinguished participants, it is a glorious moment to extend my warm wishes on behalf of Don Bosco College of Engineering to each one of you to the fifth and the last day of this short-term training program on 5G wireless communication and antenna design using MATLAB and Simulink, organized by DBC Student Satellite Club Parikrama in association with IEEE Students Branch and technically sponsored by IEEE Bombay Section, WIE Affinity Group. On this fifth day, we are glad to introduce and discuss the fifth generation wireless 5G technology, which is the latest iteration of cellular technology engineered to greatly increase the speed and responsiveness of wireless networks. If everything works, 5G would be the optimum solution, delivering complete digital connectivity from the tip of the carrier network to the customer without drilling another hole through the wall. The resource person for today's session is Mr. Uvaraj Natarajan. He is a senior application engineer, wireless communications at Mathworks India Private Limited, focusing on the 5G LTE wireless communication. Prior to Mathworks, he has worked with Cisco Systems, where he worked on self-optimizing networks (SON) for the 5G LTE market and developed expertise on end-to-end LTE networks, working closely with mobile operators across globe. He previously worked at Mirafra Technologies on LTE ENB protocol stack development, at Ericent on LTE PHY development, and at the Center for Communication Systems Research, University of Surrey on Cognitive Radios Relay Systems, LTEA, COMP systems. Uvaraj holds a master's degree in mobile and satellite communications from University of Surrey, UK, and BE in Electronics and Communications from Anna University, India. Well, from the introduction, it is very well evident that he definitely has immense expertise in the field of 5G wireless communications. I want to convey my heartfelt gratitude to you, sir, for accepting the invitation to be the resource person for this seminar on 5G wireless communications, and I would request you to kindly deliver your session. Over to you, sir.
Hi all, a very good morning, and thank you very much for the great introduction, Professor Daron. Hope my voice is audible.
Yes, sir, your voice is audible.
Okay, good. So let me share my screen, and please let me know once you are able to see my screen.
Yes, sir, we are able to see your screen.
Okay, that's great. Um, Okay, so thanks everyone once again for joining the session, and glad to see you all here in this nice morning. And sorry about the initial glitches and slight delay in the talk because of technical difficulties. So I'm happy to see a lot of people interested in this area. So today we will speak about and I also hear that this is the last day of your series of webinars, and I hope the other series were also interesting. So I would like to keep this session more explaining more on the basics of 5G, and taking you forward towards various technologies and standards which involves in 5G. So myself, Uvaraj Natarajan, and I'm a senior application engineer from Mathworks, India, focusing on the wireless products. And my primary duty is to work with the customers, working on various domains in the wireless system to helping them solving the problems and solutions. So with that note, let me start my talk. So the key takeaways for today is like at the end of this session, you will be able to have an overview of the 5G wireless communication system and learn about the 5G physical layer. And at the end, you will also be able to understand how to design, develop, and validate 5G NR features easily using MATLAB. So I've also structured this talk in such a way that we will jump into the MATLAB. So we'll see some part of the theory and we'll jump into the MATLAB, see a demo for it, and then come back to the slides. So that this will also be like a hands-on session for you to understand the various features available, so that you can, this will be like a very brief session to introduce you, and so that you can take it further for your projects and other work later on, and easily work on the system. So the agenda is like we'll start with the basics of evolution of wireless communication, and we'll see the 5G requirements and use cases, why 5G is required, and then we'll cover something on the physical layer features of 5G, what are the various factors which contributes to the physical layer development of 5G, and then we'll see the end-to-end simulation of 5G, and how to measure and test various factors in the 5G network. And at the end, we will see various resources available for you to have a look and to proceed further with your learning on the 5G. And at the end of the talk, we will take the Q&A. So at any point of time you have any questions or something, I would recommend you to post it in the chat window, and we'll be taking the Q&A at the end of the session. So you need not wait till the end of the session to take the Q&As. So I recommend you to post it on the chat window. And between each and every chapter, I will give you a small break for asking questions, so that you can post your questions, and Professor Daron would be voicing it out to me. So and a request from me, Professor Daron, if there is any glitch or anything, if you can't see my screen or hear my voice in the middle, please feel free to stop me, so I'll be able to take it further. So with that note, let's get started. Okay, so let's see an introduction on the evaluation of 5G. So we know 5G stands for fifth generation, and the basic idea is why is it called as the fifth generation, and what all generations we had earlier to that. So the first generation of communication started with analog telecommunications, which was like late 1979, where it all started with a walkie-talkie kind of communication, where I mean, there was a transmitter device and there was a receiver device, and both communicate with each other. So I hope everyone will be aware of the walkie-talkie communications, right? So that's when it all started, and then it moved to a proper telecommunication network, and then that's when we had the 2G system, where we have a mobile phone with a proper network communicating with each other. And then the beauty of 2G is it all shifted to digital from analog, and the digital communication played a very vital role, and that's when the fast technological development started happening. So once the digital communication came into picture, it's not only the voice data we were able to do, we were able to do text and other messaging data, and other features like MMS and other things which we were able to do with our 2G phones. And then came the 3G, that's the third generation of technology in the late 90s. That's when the mobile and wireless internet connection was enabled. Like you were able to browse internet on your mobile phone. Actually, it started with the later 2G evaluation with the GPRS and 2.5G kind of thing. But a proper the speed was very less on 2G in the range of kbps, and we got a proper mobile internet broadband, I mean internet connection when we got the 3G into picture. And when we talk about the 4G network, what value addition it has provided on top of 3G. So 4G network also had whatever we are using now, which is also called as an LTE network. So LTE is nothing but long-term evolution, and the idea of 4G is you'll be able to connect to the cloud and IP, and it became like a true mobile broadband system. So if you see, if you just do a speed check in your LTE devices, you'll be able to get a considerable amount of speed, which is equivalent to the broadband connection which we have in the wired network, right? So that's a kind of achievement. And the other achievement in the fourth generation is moving into the cloud and IP. So basically that's when the evolution of the best usage of our applications came into picture. Like we have mobile apps, right? So all the mobile apps are connected to the cloud, and you'll be able to access it in any of your mobile using your login ID or your mobile number with OTP or any of this as an identifier for you. So that's the kind of revolution which happened in the 4G network, where we had a lot of scope for various applications moving on to the cloud. And it's like anytime anywhere access for you, starting from your photos or your videos or your files, the OneDrive, the file sharing systems. So everything became an online cloud based system, and that was enabled because of the speed which we got in the fourth generation. And so when it comes to 5G, which is the current technology, so what is the difference it's going to make when compared to 4G? So if you see from each and every technological change, basically the generation change, the 2G to 3G or 3G to 4G or 4G to 5G, you'll find a solid point to justify the change in the name of the generation, like it's the next generation. So you should have a valid reason. Just because you are getting 20 Mbps instead of 10 Mbps speed, we can't call it as the next generation, right? There should be a valid reason. And if you see, each and every technological jump has a valid technological change, and it has created an impact in the system, because of which it is called as the next generation. That's why we call it as from 3G to 4G. And from 4G to 5G, what additional benefit 5G has brought into the system, all apart from having a better data rate, plays a very vital role. And in this session, you will see what additional benefit 5G has brought in, and you will also understand how it has brought into the system. So that's the at the end of the session, you will be able to appreciate and understand the key difference factors involved in that. Okay, so let's move on. This slide gives you a broad picture on evolution of the wireless standards. So if you see, there are various wireless standards available. So one is the IEEE standard. So if you see on the x-axis, we have the year and the generation exploration. So it all started with 2G GSM in European standard. In North American standard, we have the CDMA network, and it when the things evolved, when it came to 3G, the GSM network got evolved into the WCDMA network, and then 3.5G with HSDPA, UPA, and HSPA plus. And the same evolution happened in the North American standards, which is the IS standards, and the 3G network was called as CDMA 2000 and EVDO and so on. So the other standard which is available is the IEEE standard, which basically focused on the 802.x standard. So where you will see various evolution of 802.A, B, G, N, and that's relating to the Wi-Fi standards, which is working on the open spectrum, and that's the Wi-Fi routers and other things which you have using it. So these are like various standards, and what happened is when it came to 4G, the European and the North American standard got a kind of merged with each other, and both formed a single network called LTE. And then from then onwards, you see a single evaluation. And the IEEE standard still have the name of 802.x on its flagship. So this will give you an overview of bird's eye view of the evaluation of standards. And when it comes to the 5G standards, you will see various releases of standards. So basically, what is this standard and what is 3GPP? So 3GPP is third generation partnership project, which is dealing with defining the standards, and it defines it's a body which is a group of members. And if you see, there will be active participation from almost all the market leaders in the industry into the standardization body. So the duty of the standardization body is to define how an equipment or how a technology should work. So that's the reason you are able to build the technology very fast, because the standard defines how the technology should be built. And the manufacturing companies or the technological companies build the system, for example your mobile phones or the network devices or network components, based on the standard defined by the 3GPP. So on that note, you will see the the 5G standard started from 2018 with the release 15 of 3GPP, and the second release of 5G specification is on the release 16. That has just now come into the picture. So this picture gives you an overview of when was the standardization started and came into picture for the 5G network. Going forward, if you are interested in knowing more about the standard, all the standard documents are available for you to have a look, and it's free for you. You can just log on to 3gpp.org, and then or just search for 3GPP standard on 38 series. So basically, the 38 series deals with the 5G, and each and every standard document defines how each and every component should work. For example, if you see 38101 explains how a user equipment is nothing but our mobile phone should do radio transmission and reception. So likewise, each and every document defines each and every part of the standard. So you can make a note of this URL in case if you want to dig further and download the standard and read it by yourself. I would also recommend you to take some notes in case if you want to refer further, and we will also get this slide deck at the end of the session. Okay, so this slide gives an overview of the peak data rates which are available. So if you see The GSM started with kbps, and then 2.5G started with hundreds of kbps, and with 3G you had a speed in mbps. So in LT, in release 8, we had maximum speed of 300 mbps, which can be achieved using the network. Okay, so with that, let's quickly move on to the 5G requirements and use cases. So as we discussed, 5G should give us a kind of a new technology or new use cases in order to make it different from the other evaluation, right? On that aspect, what are the new applications which are available as a part of 5G network? So if you see, you'll be able to enjoy the 4K, 8K or 360-degree videos. You will be able to use the virtual reality and connected vehicles and Internet of Things. All those comes into picture when it comes to the 5G network. So on that note, the 5G releases have been divided into three different parts. So one is the release 15 of the standards, which falls under the enhanced mobile broadband features. So that's again like the base standard, which helps in increasing the or enhancing the data rate in the mobile broadband of greater than 10 Gbps of speed. And the next one, which is a part of the release 16 of standard, is ultra reliable and low latency system. So this is very much important when it comes to the Internet of Things and machine to machine communications, where the latency of the system should be as less as possible. And then the third part of the release, which is release 17, is expected for the massive machine type communications. So that's again explains how a lot of machines communicates with each other and the protocols involved and so on. So these are like various differentiating factors from the fourth generation system and added newly to the fifth generation system. So where it's not only you using the mobile phone for all the work which you do, like the mail, the videos, the cloud-based system, but it's also to the machines to communicate with each other, or the things to speak to each other. So all those things comes into picture when it comes to 5G network. So this is going to create an new evaluation or new revolution into the telecommunication networks. Okay, so the base question here is how is 5G going to handle this much amount of data rate? So we saw, right? I mean, we saw in tens of Gbps of data rate. How is 5G going to handle it? So uh, the base formula, if you are from the electronics and communication department who has studied the wireless communications, so the base formula to increase the capacity of any system is by increasing the cell density, or increasing the spectral efficiency, or increasing the available spectrum. So all these three are directly proportional to the increase in the capacity. So if you want to increase the capacity, the first start is you should increase the cell density, which is nothing but put more number of cells. So cells here, which means the base station, or in 5G terms it's a G node B, or people in layman terms call it as cell phone towers, right? So those are like should be closely packed with each other by increasing the cell density. And the next part is the spectral efficiency. So spectrum, as you know, is very costly resource. So how efficiently we use the available spectrum in hand plays a very important role, and this is where the engineer's role comes into picture, where the designing of the system plays a role here. And the next one is the available spectrum. So if you have a spectrum, for example, if you want to increase the capacity, instead of having one part of the spectrum, the operator can buy two part of the spectrum. This will increase the capacity by 2. So this is one of the option which you can. So all these three things are directly proportional to increasing the capacity. So on that note, 5G defines two different frequency spectrum, FR1 and FR2, which is frequency range 1 working on less than 6 gigahertz of bandwidth, and so that is something which we call it as sub 6 gigahertz band, and the FR2 working on 23 to 56, 53 gigahertz bandwidth, and that's again called as FR2 of operation. So this new spectrum of FR2 is newly introduced in the 5G network, and this will again help in increasing the capacity of the system, since we had a very high bandwidth available there. So as we saw in the previous slide, there are various technical solutions available to increasing the broadband data rate. On top of that, when it comes to an engineering work, right, so increasing the spectrum is up to the operator to buy a new spectrum. But how efficiently the spectrum which we have is used is in the engineer's hand to make it used in the more efficient way. So on that aspect, there are various factors in it, like you want to design a new physical layer which is efficient as possible. We need a new RF structure with a nice design of power amplifiers and the new antenna design and massive MIMO. So all those things comes into picture when it comes to adding on to the value of the 5G system. Okay, let me take a quick pause here and ask that if you have any questions.
No questions, sir.
Okay, cool. Okay, let's move further then. So in the second part, I would like to introduce you to some of the basic wireless communication concept before we jump on to the 5G as such. So if you see the base station or the cell phone towers in 5G is called as G node B, which is nothing but the GNB, and what we call it as a UE or a user equipment is your mobile phone. So these are like basic technical terminologies which are used, and the data when it is transferred from the G node B to UE is called as downlink, and when the data transferred from the UE to G node B is called as uplink. And again, there are various duplexing technologies. So the basic ones are like FDD, which is frequency division duplexing, and we have two, and this basically uses two different pairs of, a pair of frequency or two different frequencies, one for the uplink and one for the downlink. And the other part is the TDD or time division duplexing, which is like sharing, the both uplink and downlink sharing the same frequency resource, but time divided with each other. So these are like two different duplexing techniques available. And so when it comes to 5G, OFDMA plays a very important role, where it's used for the 5G uplink and downlink transmission scheme. So this is nothing but a multi-carrier transmission scheme. So the complete band channel bandwidth which you have is divided into various small subcarriers which are orthogonal to each other in order to make the communication possible. So the advantages of using OMDMA is it's more robust to multipath fading and high spectral efficiency, and it's also low complexity in implementation when it comes to the digital domain, and it's also allows us to do frequency selective scheduling, and also help us with our new MIMO and massive MIMO transmissions. So all those things are easily enabled using the OFDMA. And again, coming on to the MIMO, which is nothing but the multiple input antenna technique. So where we have multiple antennas in the transmitter and receiver, which is used to transmit the data. So again, this technical feasibility of having multiple antennas basically allows us to increase the diversity of the system, So basically, there are various mechanism where you have you can increase the transmit diversity or receive diversity, or you can also use this multiple antennas to do spatial multiplexing and beamforming as well. So these are like various ways this can be used, and the importance of using the MIMO technique is it will help you in boosting the overall data rate, and also increase the reliability of the communication link based on the design which we do. And this slide gives you a quick a comparison of LTE to 5G. So LTE is like fourth generation and 5G is fifth generation. So moving from LTE to 5G, what are the various differences? I mean, the massive differences which comes into picture. So the first main is the LTE enabled us to use mobile broadband, but 5G has more use cases as we discussed earlier. It has decreased the latency, and LTE uses only sub-gigahertz frequency FR1, and 5G uses two different frequency ranges, and hence because of which we have a higher bandwidth to operate, and we have variable subcarrier spacing. So subcarrier is nothing but um, uh, the various subcarriers which are available in the OFDM system, and so it will also allow you to use various bandwidth part instead of need to decode the whole bandwidth. So we'll see what is a bandwidth part in the forthcoming slides. Okay. So how does a 5G waveform look like? So 5G uses OFDM with cyclic prefix. So OFDM is orthogonal frequency division multiplexing. So this is again a new type of multiplexing system which came in the LTE network itself. And 5G uses the CPO FDM. So CP is cyclic prefix based orthogonal frequency division multiplexing. So this slide, this picture gives you a quick comparison between the LTE and 5G. So in the LTE network, we had the base OFDM where we had a slight guard band which is required between two different signals because of this particular spectral leakages, and so 5G again uses windowing or filtered OFDM or VOLA technique to increase the spectral efficiency. So if you see the difference between the base OFDM and the windowed OFDM, so you have a very steep curve here in order to make it very much not interfering with the neighboring bands, and hence you can use this space in the 5G, which is again increasing the number of RPs in the 5G network. So that's one of the enhancement which has gone into the system. And I would also like to introduce you to the resource elements and the resource block. So the resource block or the resource, basically this is called as a resource grid, and this concept again started with the LTE network where we had various a big resource grid. And if you see the resource grid, we have the OFDM symbol on the time axis, which is the x-axis, and the subcarriers in the frequency domain or the y-axis. So if wide band is converted into n number of subcarriers, so all these, each and every y-axis component corresponds to one subcarrier, and each and every x-axis component corresponds to the OFDM symbol. So this is called as resource grid, and a resource block is a small element of a resource grid, which is again consist of 12 subcarriers. So if you see here in the y-axis, which is for the subcarrier, so you will have 12 of these boxes for which constitutes a single resource block. And when it was in LTE, it was like you had 14 OFDM symbols for normal CP. So you had, we had like seven OFDM symbols into one subcarrier, making the resource block. But in 5G, we have only one OFDM symbol and 12 subcarriers forming a resource block. So the idea of creating a resource block from this grid is each and every user should be allocated at least one resource block for the transmission. So this again increases the spectral efficiency, and each and every box here is called as resource element, and this is the smallest physical resource which is available in the system. So this is like a basic building block of the 5G network. And if you see the frames, so how the data will be transmitted in the form of frames, right? So how the 5G frames look like here? So we have a 10 millisecond length frame in 5G, and each frame consists of 10 subframes. So every 10 millisecond is divided into 10, and we have 14 OFDM symbol per slot per subframe. So that's like each and every subframe has a 14 OFDM symbol. And the beauty in 5G is the variable, the subcarrier spacing is variable. So if you see, as far as LTE is concerned, we had a fixed subcarrier spacing of 15 kilohertz, but in 5G you have a variable subcarrier spacing from 30 to 240 kilohertz. So the basic idea of making the subcarrier spacing variable is to make sure you have the flexibility in usage. For example, increase in the subcarrier spacing, you will see there is an increase in the nominal max bandwidth, where you had 50 megahertz approximately when it comes to 15. But when we go to 240 kilohertz of subcarrier spacing, we can support up to 400 megahertz of bandwidth. So that has a drastic increase in the supported bandwidth, and hence you have the flexibility to work. And another important factor is we have the minimum scheduling interval again varies. So what this means is, like for a single user, we can schedule a particular data in first millisecond, and the next data can be scheduled only in the second millisecond. So the system has to wait for one more millisecond in order to schedule the data for the user. But when it comes to variable subcarrier spacing, so when the subcarrier spacing increases, your scheduling interval decreases. So within 0.625 millisecond, you'll be able to schedule data, and hence the flexibility for the system to dynamically schedule fast data to the user increases, and hence ultimately the latency and spectral efficiency increases. So that's one of the important factors here. And as we saw in the previous slides regarding the slots and the OFDM symbols, so we have something like a single subframe that's again equivalent to a single slot of 1 millisecond, and each and every 1 millisecond slot for 15 kilohertz subcarrier spacing. And when we increase the subcarrier spacing to 30, the slot length reduces to 0.5 milliseconds. So this is like the slot length reduces as we increase the subcarrier spacing, and hence you will have more flexibility for the scheduling as well when the increase in the subcarrier spacing happens. So even though 5G supports variable subcarrier spacing, how the orthogonality is maintained between these variable subcarrier spacing again plays an important role, right? So on that note, if you see all the subcarrier spacing starting from 50 or 30 or 15 or 30 or 60, whatever it is, you will see the start of the symbol aligns with each other. So even in the next symbol, you will see this slot of the symbol aligns with all the subcarrier spacing. So this makes sure that the orthogonality of the system is maintained when we use this particular formula for calculating the subcarrier spacing. Okay. For each and every, so let's see how the system is defined from a very base. So whenever we start with designing a system, we start with defining a carrier, and for each and every numerology, a single carrier is defined, and a carrier is something like characterized by subcarrier spacing and the number of resource blocks and starting resource blocks and all those things, and each and every carrier corresponds to a resource grid. So earlier we saw a slide where we had a picture of grids, right? So this is something like mapping to that. And in this particular picture, there are two different carriers defined, one in the green color with 30 kilohertz subcarrier spacing, and one other one in the blue color with 15 kilohertz subcarrier spacing. So once the carrier is defined, we'll end up defining the bandwidth parts. So BWP stands for bandwidth parts, and the reason for having the bandwidth part is we'll be able to define a carrier with an addressable bandwidth. And what happens here is for example, your receiver, right, your mobile phone, when we move from LTE to 5G, the spectral range increases drastically, right? From 20 megahertz to 200 megahertz and 400 megahertz. So in that case, your mobile phone should be able to tune on to the complete bandwidth in order to understand, decode, and understand the data, correct? So when this comes to a very high bandwidth, then your mobile phone will end up tuning on to very high bandwidth, and hence there is a power wastage there, and also there is a delay because of the processing speed, or if you want to increase the processing speed in that case, so there is a wastage in the resource because of just tuning on to the complete bandwidth, right? And it's not only to the mobile phones. When it comes to um, the IoT kind of devices, right? When it comes to very power sensitive devices like your dongles or other things, so I mean, it need not scan the complete bandwidth in order to find the data for it, right? So the device should be able to operate in a limited bandwidth, even though the available spectrum is very high in 5G. So on that regards, there is a concept called bandwidth part which is introduced. So even though the spectrum of the system is very high, the user will be able to tune on to a specific bandwidth assigned to him. So in this case, we have defined a bandwidth part of 15 kilohertz subcarrier spacing with an offset. So we define the location of the bandwidth part for that particular user, and user will be able to tune in only to that particular bandwidth part, and hence he'll be able to get the data easily with very less power usage and very less overhead. So this is one of the important concept which is introduced in 5G. And if you see, a UE can be configured up to 4 different bandwidth part and only one bandwidth part active at a time. So what this mean is, so here the x-axis is the time axis. So for example, consider a single user or a mobile phone which is having which needs less data transfer happening. So on that aspect, in time one, it can be allocated a smaller bandwidth part here which is active, and the device thinks that whenever you start using it, and when the device thinks that it needs a bigger space for transmitting data, it gets allocated a bigger bandwidth part in the time 2. And once you stop using the data, it goes back to the older bandwidth part. You can configure a smaller bandwidth part for that. And once you start downloading a video and a high quality video or streaming something, so in that case, if you need a bigger bandwidth, so the system allocates a bigger bandwidth for you. So in this case, if you see the flexibility depending on the data usage, so if your mobile phone is idle, it will just go with the basic bandwidth part which will enable you to do basic signaling transmission and no data. And whenever you want higher data, that as you see in the time 4, you'll be able to get a bigger bandwidth part. So on that note, the system will be able to cleverly allocate bandwidth to user who wants the data, who wants the bandwidth, and not for others who is not using the system. So on that aspect, the system is cleverly designed in such a way that the spectral efficiency again increases. So okay, so this is with regards to the complete bandwidth. So there is one more concept called core set, which is introduced in 5G. So core set is nothing but control resource set. So this says where the control data for the user is available. So as we discussed in the earlier slides, right? I mean, we have a very big bandwidth available for the 5G, and control data is something which every user should get in order to understand where the real data for it is available. So each and every UE will need to decode the control data. And if the UE wants to decode the complete bandwidth again to get the control data, again, it's a waste of time and energy, right? So on that note, a core set is defined which says where the control data is available for that particular user. So it's predefined by the network, and the user will be able to understand where the control data is available for. So as you see in this particular picture, the green color is something where the control data is available. And so whenever when you switch on the mobile phone, you will see the control data. You will tune only in this particular green color area in order to get back your control data. So this is like another important feature which is added in the 5G network. And also when you compare it with LTE network, even the DC subcarrier is modulated in 5G, because in LTE, it's all centered from the DC subcarrier. So all the user will be allocated with reference to the DC subcarrier for that particular bandwidth. But when it comes to NR, the DC subcarrier is modulated, and each and every UE can be allocated the resources in a different area because of, again, thanks to the bandwidth part introduced in the network. Okay, so I would also like to give a pause here. So we discussed about the basics of basic building blocks of the 5G network. So any questions on any of the previous slides?
Sir, there is one question about NORMA, that is non-orthogonal multiple access.
Okay.
Yeah, whether there is any simulator in MATLAB for it.
Okay. So you will be able to see the OFDM modulator and demodulator readily available as a part of the MATLAB suite. But again, non-orthogonal system, again, that comes as, again, you can consider that as your base TDM based and CDM based system. So so that again you'll be able to take it up. I mean, so OFDMA is like a ready-made available function for you, but non-orthogonal multiple access is more into the research area of things where people do research on the advantages and disadvantages of it, and you will have to build your own systems. There is no ready-made function available, so you'll have to build your own functionality for simulating the non-orthogonal system.
So, and one more question, they've asked how to simulate the supporting components for 5G wireless technology with MATLAB.
Okay, so that's coming in the next section. So maybe we'll take this up at the end of this.
Yes, sir. Yes, sir.
I think mostly that'll be answered when we move on to the next.
Yes, sir.
Right. So let me move on to the next part. So let me also introduce you to the 5G toolbox available in MATLAB. So So you will see a toolbox called 5G Toolbox, which will enable you to simulate the various components of the 5G network. You'll be able to generate the 5G standard-based waveform. You will be able to do a lot of measurements, and you'll be able to build each and every block of the 5G physical layer system and do an end-to-end simulation of the system. And once you are done with the simulation, you will be able to connect it to the hardware and then do hardware based over the air testing using MATLAB. So this is an overview of the system. And the benefits of the toolbox is you have all the 5G specific functions and examples which are defined, and you'll see an extensive documentation. So I will walk you through the documentation against how you can see and understand. And you'll also have the MATLAB source code where you'll be able to open the code and understand the implementation and then work on top of it. And last but not the least, the C code generation support, where you'll be able to generate the C code and proceed further when you have a C based framework. Okay, so let's move on to the waveform generation part. So you'll be able to generate a waveform for all the standard specific functionalities like 5G, LTE, WLAN, Bluetooth, so all those things. You'll be able to generate the waveform as a part of the MATLAB features. And you also have a nice app-based waveform generator where you'll be able to generate the waveform just by click of a button. So again, standard also specifies a list of waveforms which has to be supported, and using the toolbox you will be able to generate the standard specific waveforms for the testing purpose. So let me quickly move on to MATLAB and show you the waveform generator. So this is the MATLAB window. So if you are new to MATLAB, I would recommend you to start with the documentation. So the documentation is like a very extensive a set of features where you will be able to learn and understand how the system behaves. So if I just click on the 5G toolbox, so on this you'll be able to see how the standard specific 5G is implemented in MATLAB, and we have various examples available, ready-made examples which are available as a part of MATLAB, where you'll be able to understand each and every functionality starting from downlink, uplink, if you're looking for an end-to-end simulation or if you're looking for a system level simulation. So you'll be able to understand each and every component of the system which is implemented and which is readily available as an example for you. Okay, let's move on to the waveform generation application. So there are a lot of applications which are available in MATLAB, and that's available in the apps tab. And if I just click here, you will see various applications which are readily available. I'm interested in the wireless waveform generator application. So here, if you see, this is a nice GUI which is developed and which will enable you to simulate various standard specific wireless waveforms starting from 5G, LTE, WLAN, Bluetooth, and then the custom modulation. So let's go on to the 5G part of it. And even in the 5G, if you see, we saw about various frequency ranges, right? So FR1 and FR2, you will be able to select which frequency range you want to operate, what modulation and coding scheme you want to operate, what subcarrier spacing you want to operate, what is the channel bandwidth you are interested in. So all those things can be easily specified for you here. And then just by click of a button, you'll be able to see, generate the waveform, and you'll be able to see the waveform here. So you see the spectrum analyzer with basically here we have selected a channel bandwidth of 5. So we saw the 5 megahertz spectrum, and these are like various channels and signals of the 5G which is directly populated here. So I just changed this to 10, and it's not only the waveform. So this is a basic waveform without any imperfections. So if you are looking for adding any noise or any other offsets, frequency offset, phase offset, or DC offset or IQ imbalance, you will be able to add all those things easily as a part of the impairment. And here I've just added an AWGN of SNR 20, and then I just click generate. You'll see the same signal added with the noise. So you see the difference from the earlier signal, right? And if I further increase the SNR to 50, you'll see a better signal, see when compared to the old signal, because the SNR is improved here. So on this aspect, you will be able to analyze how the system or the waveform looks like for each and every impairment which is added. So once you have generated the waveform, you can export this directly to the workspace or to a file, and I will be able to use it directly as a ready-made waveform which is available for you in terms of and use it plug into your MATLAB based framework to proceed further with your project. So let's quickly move on to the presentation. So as a part of the waveform, you'll be able to simulate all the physical layer channels and signals. So these are like various physical layer channels and signals which are available. So let me introduce you quickly to those. So the synchronization signal is nothing but whenever you switch on a mobile, this synchronization signals comes into picture first, where you'll be able to your mobile phone will be able to latch onto the network. So for that you need the frequency and time synchronizations, right? So all those things happen as a part of the PS and SSS. It's nothing but primary synchronization and secondary synchronization. So once the synchronization is obtained, then the mobile phone will be reading the broadcast channels in order to understand what cell it belongs to. So that's again done by the broadcast channel, which is physical broadcast channel, or PBCH. And whenever the user equipment or the UE is out of sync with the network, and the UE is trying to connect to the network because there is a kind of uplink data, or whenever you are trying to make a call or send a message, there is a user initiated traffic which is coming to the network. So on that, so before you make a call, there is a RATCH process which is happening in order to sync to the network, and after which your call will start going. So that happens through PRAT channel, and that's nothing but physical random access channel. So these are like the basic connectivity channels and signals. So once that is done, you will have the main control channel and the data channel for both uplink and downlink. So this will help you to basically send the user data both in the uplink and downlink direction. And for example, PDSCH stands for physical downlink shared channel, and PUSCH stands for physical uplink shared channel. So this channel carries the user data in the downlink direction, and where the user data is located is indicated by the control channel of the corresponding data channel, which is nothing but the physical downlink control channel, or PDCCH, and the corresponding uplink one is called physical uplink control channel, or PUCCH. And there are various reference signals apart from the control and data channels like DMRS, PTRS, CSARS. So these are like reference signal in order for the UE and the G-Node B to understand how the channel looks like. So based on the channel, the dynamically configuration for the modulation and coding scheme happens in both the directions in order to mitigate the channel effects. So again, channel plays an important role. So channel, what is a channel? So channel is something like the air interface which comes in between your transmitter and receiver. So when it comes to 5G, where we have the massive MIMO and lot of additional new features going in, then arises the need for having a 5G specific channel model. So if you see, 3GPP has implemented a 5G specific channel model as a part of this standard, that is TR 38901, which talks about how a channel model for 5G should look like. So basically, it speaks about the TDL and CDL, which is tapped delay line and the clustered delay line profiles, which mitigates the 5G effects which comes into picture. So it's not only the 5G channel models, you will also be able to simulate various other propagation channels, such as free space path loss or RF attenuations due to atmospheric gases. So you see a lot of atmospheric gases, which again plays a vital role when we move on to the higher frequency range, right? FR2, which is happening on millimeter wave of communication. So for that millimeter wave communication, we also see a lot of atmospheric gases absorption happening, and also attenuation due to fog and clouds, basically due to the weather conditions and hilly areas. You'll see a lot of attenuation happening on that aspect as well. And again, the MIMO multipath fading channel, or the scattering MIMO channels, all those things has to be introduced into the system in order to make your system more robust. So in order to make your design more robust, so that when you implement the same design in the hardware, you will see less surprises there. So that's the main idea, to introduce as much as close to the physical physical availability. So on that note, if you see end-to-end simulation, so these are the various blocks and the transmitter and the receiver side when it comes to the end-to-end simulation. So we have DLSEH, which is nothing but downlink shared channel, which is again giving input to the PDSEH, which is the data channel which we saw, right? And after which we have the precoding block and the CPU OFDM, and the OFDM modulated symbols will be sent to the channels. So this can be various channels which we saw earlier. And again, on the receiver side, you will see the complete receiver chain, which is available as a part of the building blocks in the 5G toolbox. So you'll be able to receive it, synchronize it, demodulate it, do a channel estimation, and then neutralize the channel effects, and then decode the signal, and then they receive the data. So this is like giving you a complete end-to-end link level simulation for the PDSEH channel. So this is on the downlink direction. So likewise, you will also be able to simulate the complete uplink, so through various uplink blocks which are available as a part of the system. And you'll also be able to simulate the synchronization blocks, like how we have we saw about the primary synchronization and secondary synchronization, right? So this is like, I don't want to go much deeper, but there are various locations, fixed locations where this channels lies actually. So in the resource, for example, if you consider this block as the resource grid which we saw earlier, your primary synchronization sequence sits in a single location, and once the UE decodes the primary synchronization signal, it will get one out of three possible known sequences, which will provide the timing estimate. And then after getting the PSS, the UE will try to decode the SSS part of it, and decoding the SSS, the UE will get again one out of 336 possible sequences, which will again be synchronized. And having these two values together, the UE will be able to get the cell ID of the system. So cell ID is nothing but the G-node base cell ID. And so that will be again like there are 1008 possible combination of cell IDs possible in 5G. And once the cell ID is obtained, you'll have the next guy to decode, which is nothing but the broadcast channel. So we saw PBCH, right, in the earlier slide, which broadcasts the network basic information. So using which you'll be able to get the MIB, which is the master information block. And once you got the MIB, you will be able to get the SIB, which is the system information block. So there are various SIBs which are available, which provides various level of information to the user. So basically, if you see the user UE, right, the user equipment is a passive device. So all the information for the UE is provided from the G node B. And how the G node B provides information? So it's through the basic information is through MIB, and all other information is through SIB before it connects to the network. So once the UE connects to the network, it will get further information about the authentication and other stuffs through the control and the data channels which are on. Okay. So cell search and selection procedure plays a very important role when you are working on the receiver part, right? So you need to obtain the cell ID, search for the cell. You need to obtain the cell ID and decode the MIP. So these are like various blocks which are involved when it comes to the complete receiver operation. For example, you start with the burst generation and then do a beam sweeping and then add propagation channel to it, and even on top of that you add AWGN to it, and then you design the complete receiver. So this is like the simulation of the for the cell search and the selection procedure. So we have a ready-made example using which you will be able to do the cell search procedure, which is again part of the 5G toolbox. Okay, moving on to the next segment of measurement and testing. So once you design your system, you have the waveform and you design the end-to-end system using various available ready-made blocks in the system. So you'll be able to use all those blocks and construct an end-to-end link level simulation. So what after that? So you should be able to measure the performance of the system, right? So there are various measurements which are like very critical factor, and one of those is the ACLR measurement. So that's adjacent carrier leakage ratio, so which defines the ratio of transmit power on the assigned channel to the receive power on the adjacent channel. So how far your channel leaks to the adjacent channel plays a very important role in order to not create interference to the adjacent channel. So when you are doing testing, you should make sure that your channel does not create interference to the other channel. So what's the solution for it? You need to design filters. So you need to design filters in such a way that you should be able to mitigate the interference to the other channel. And what standard has does is standard has defined a threshold. So for example, in this figure, if you see, so the figure A is like without filter and figure B is like with filter, and the standard has defined a threshold, and the ACLR ratio should be above that threshold in order to make sure that the leakage to the adjacent channel doesn't happen. So if you see, we have done an experiment and we have created an example using which we have designed the sample filter, and applying that filter, the leakage to the adjacent channel has reduced a lot. And this is again will give you a good idea on how a filter design should look like. And after ACLR, again another important measurements is the EVM measurement, which is nothing but the error vector magnitude. And this is the measure of accuracy of the radio transmitting symbols within its constellation. So if you see the constellation diagram here. So the radio should be able to transmit the signal within the constellation and without any leakage happening, and which will again you'll be able to simulate the complete EVM measurement by adding various RF impairments like phase noise and non-linearities, and then do the receiver operation to measure the EVM of it. So we have again ready-made example supporting it. And when it comes to 5G, we have various reference signals, right? So using the reference signal, you should also be able to do measurements like RSI, RSRQ, received signal strength indicator, and then the quality of the signals. All those things can be easily measured using MATLAB and using the ready-made example, which is. So once you are done with the basic software related measurement, what next? So the next one is the moving on to the hardware, right? And then doing a over-the-air kind of testing with SDRs and RF instrument. So if you're working on any institution, so you would have seen a lot of RF signal generating and the capturing instruments. So you'll be able to connect the MATLAB into the RF signal generating instruments, and then do transmit the waveform directly into the air. And if you have another RF capturing instrument, capture the waveform which is generated into that, and then take it back to MATLAB and do the analysis of the waveform. So it's not that you need to have an RF capturing equipment. So you can also do the same with the various supported software-defined radios, which are available as a part of support packages in the MATLAB. So again, the same work can be done. You can be able to connect the SDRs to the MATLAB and then generate the waveform, pass the waveform through the SDR, and then transmit it in the air. And then the receiver side, you'll be able to receive the waveform and then take it back to MATLAB and do analysis on it. So these are like various SDRs which are supported as a part of the MATLAB environment. And how do you install the support package? It's very easy. So there is a add-on button, and when you click on that, you get hardware support package. So this is like a driver for the hardware. So you just get the hardware, connect it to your system, and then install the support package. So it's ready for you now, and you can just use it as a plug and play system where you just plug it and then do a transmission of the transmitting and receiving of the signals instantaneously. Okay. Let me also explain about the customer story. So we have various customers all around the globe using the 5G Toolbox for various applications. So one of our customer from India, Leica Wireless, have used the 5G Toolbox for independent design, analysis, and verification of the physical layer stack development. And it's not only we also have various customers across the globe, maybe Qualcomm, Covidia, Nokia, Huawei. So all the customers have used 5G Toolbox for the efficient IP development. And our customer have also seen a small team was able to achieve the work much faster using MATLAB 5G Toolbox, and hence the time to market and the productivity have increased. And in order to learn more about 5G Toolbox, I would recommend you to go through the Mathworks product page for 5G. And if you are new to 5G, I would recommend you to go through various videos we have as a part of the 5G explained video series, which is again available as a part of the Mathworks website. So there is also a nice white paper talking about testing of 5G NR devices with the standard waveforms. So this is how you learn more about the technology as such. And any questions till now, I'd be happy to take on the previous slides.
Yes, sir. There are some questions. One of the question is how to measure the losses in between in the channel between the user and the base station.
Excellent question. So that's where I showed you the channel models, right? So various channel models. So what you can do is you can build the complete the transmitter model. So as you saw. Okay, as you saw in this particular slide, right? So we have so you have this as a ready-made example as a part of MATLAB, where you have the complete transmitter model, and the channel, the output of the OFDM is given to the channel, and the channel is sent to the receiver. So on that basis, you will be able to measure the noise which is due to the channel. So it's not only this particular channel, you'll be able to add a lot of other imperfections as we saw in this slide, right? So you'll be able to add a lot of imperfections and then check how your system behaves after adding all those imperfections, after you receive and decode the signal.
Okay, sir. So, and one more question is that how to estimate the channel when the user is moving fast. So there is some Doppler effect which has taken place and the coherence time is very short while using the OFDM signal, and if at all the
Right.
OFDM signal duration and training symbol is limited.
Right. So this is also an excellent question. You can introduce various. So when it comes to real time, right? For example, a user moving in a car or a train in a very high speed, you'll see a lot of Doppler effect coming into picture based on the rate in which the user moves. So this Doppler effect can also be introduced into the system using the Doppler function available as a part of the comms toolbox. So you'll be able to add those imperfections to the channel. Yeah.
So, and can you throw some light on the beamforming part in MATLAB, if at all?
Okay. So yeah, beamforming again is a separate area by itself. So if you are looking for learning about the beamforming, I would recommend you to maybe I'll send a link on top of it, or we have a nice example and a nice e-paper for beamforming. So if you just type beamforming MATLAB e-paper, so you see here you'll land up in the uh, Mathworks page. So this will give you a very good understanding of what a beamforming is and how it can be implemented. So you'll see nice videos again on that. So we have a nice white paper which explains about the hybrid beamforming. Feel free to go through this. So yeah, that's a good question. Yeah.
Yeah, thank you, sir.
Okay, so we'll proceed further and take further questions later on. So let's see how you'll be able to use MATLAB in your academic work. So basically, to introduce MATLAB is deeply rooted in educations where we have 6,500 plus universities around the world using MATLAB, and you have more than 2,000 plus MATLAB and Simulink based book available where you'll be able to do your academic research or teach your students or anything based on the MATLAB. So that's the kind of overview. And if you want to learn MATLAB and if you are new to MATLAB, I would recommend you to go through the MATLAB on LAMP or Simulink and LAMP, or if you are looking for doing any deep learning based work using MATLAB, I recommend you to go through the deep learning on RAMP. So basically, these are like three different free courses available as a part of the Mathworks website, and the only thing which you have, I mean, need for that is your Mathworks ID. That's it. You can just register free for a Mathworks ID, and then you'll be able to sign into those courses and go through it on your convenient time. So it's not only those courses. We have very extensive fundamentals and other courses which are available as a part of the online academy suite. And I would also like to introduce you to MATLAB Online, so where you'll be able to access to MATLAB through the online web-based browser. So what happens here is you don't want to download and install MATLAB, and you don't want to worry about various version consistencies and also file sharing between system. And the idea is you'll be able to access MATLAB everywhere wherever you go. So basically what happens here is I will just show you the MATLAB online system. So you'll have to log into matlab.mathworks.com. So you will see in the web browser a similar kind of window which you see in the MATLAB, and you'll be able to do all the work which you do in MATLAB in the same kind of command window. And what happens here is this is connected to my MATLAB drive. So whatever files you place in the MATLAB drive, like your OneDrive or Google Drive, so whatever files you place in the MATLAB drive, you can just put your file in your desktop, you work on it, and then you can put the file in the MATLAB drive, and you can open this particular MATLAB drive anywhere from the web browser and pull out the same files and start working on it. So basic idea is you'll be able to use MATLAB anywhere. The only requirement here is you should be able to have the valid Mathworks ID for it. So again, you'll be able to use the command window. So you see, I'll be able to do all the operations, whatever I do. So I'm just adding two numbers. So whatever I do in my MATLAB window, I'll be able to do it online in the MATLAB drive as well. And again, you'll be able to open any examples and run the complete script using the online-based systems. That's one of the interesting thing. And it's not only the drive, you'll also be able to use MATLAB in your mobile. So there is an application available for you to download and install in both in Google Play as well as Play Store, App Store, and you'll be able to use MATLAB command window and other things in your mobile as well. So the idea here is this application in the mobile will be able to access your mobile's camera and your accelerometer and other sensors. So idea here is you'll be able to take the mobile data or the sensor data, capture it using your mobile, and then take it back to the MATLAB and do kind of project work based on it. So this is like make your work very easy by giving all the fundamental functionality by accessing the camera and other sensors. And I'd also like to introduce you to MATLAB Central, where you'll find answers for almost all your technical queries. You'll be able to participate in the coding competitions, or we have an extensive blog where you'll be able to understand various technologies written by the technology experts. So all those things are available as a part of the MATLAB Central. And if you are looking for any specific training, so again, Mathworks provide dedicated training services based on the customized need of the institution, and there are various courses and offerings on almost all the areas, which can be again customized. So that's it from me. So I've given my email ID and LinkedIn for reference. So feel free to contact me for any queries or any doubts which you have, which you might get in the future as well. So with this note, I'm open for questions. So we can take the remaining questions now.
Yeah, thank you so very much for the session full of knowledge about the fundamentals and the latest trends in 5G technology. We shall now move on with the question answer session. So, sir has already answered a few questions. So we shall continue with the other questions. So,
Yeah, I'm there.
so there is one question about the frequencies used for 5G in India. So, what are the factors which are considered while choosing the frequencies for 5G communication? And there's a question like, is 60 gigahertz better than 28 gigahertz?
Okay. So so the various factors in the sense basically 5G enables I mean as a technology enables us to move from sub-6 gigahertz to millimeter wave operation. So that is again very high spectrum of operation, and it's not only to India, it's basically carved out spectrum for throughout the world, where the user will be able to define, and it's basically what range of the spectrum is decided by the government, right? So all the government norms comes into picture when auctioning the spectrum, and what spectrum is available in which country. So those are like regulatory aspects when it comes to allocating the spectrum. So Again, the millimeter wave operates from 20 plus gigahertz to 50 plus gigahertz, and again, there is no hard cut, so there is work going on designing a very high range of spectrum as well. So those are like area of investigations further, and um, you'll see those things as and when the regulatory bodies evolves. And as far as technical difficulties are concerned, when we move to the millimeter wave of operation, there are various other difficulties when designing a system, right? It's not only the for sub-gigahertz, the attenuations are something different, but when we go to millimeter wave, we are going to work on very high frequency with a very big bandwidth. So we have other technical difficulties to solve, like what we saw in the other slides, right? So all those things are again addressed as a part of the 5G standard. So
Yeah, thank you, sir. So the next question is, for MATLAB online, do we get
right.
access to GPU and parallel computing toolbox as well?
Okay, so basically, the GPU and parallel computing toolbox are focused when you want to serialize, I mean, parallelize your work, right? So on that note, the idea of using the GPU is to speed up your simulations. If you are running on a very high process-oriented simulation, I would recommend you to use the desktop application with various cores of CPU or a GPU. So MATLAB online won't be the choice for you in that. So I would recommend you to use the desktop computer with various cores for that, yeah, in order to use the parallel computing.
So with respect to MATLAB online software, there's a question which says that can the students access it with some login credentials, and how much is the cost if they can access it?
Oh no. So if you have a MATLAB license, and if you have a MATLAB account tied up to that license, so you'll be able to use MATLAB online. There is no separate cost involved in that.
One more question is about which are the key areas in 5G communication having a scope for research. So can you brief us about that?
Okay, so that's a very good question. So you can think of basically it depends on what area. So if you want to work on the algorithm part, or if you want to work on the antenna part, the RF part. So depending on your expertise, you can choose various area of work. For example, if you're working on the antenna and the RF, then you can choose the millimeter wave. And you can see how massive MIMO antennas and phased array antennas are built. So all those things can be used. And if you are looking on the baseband part of it, then you can choose various, for example, coding schemes, enhancing the LDPC coder, uh, or various algorithms on that area. So it depends on your area of interest or your area of work. But again, there is a huge scope for research and development in that area.
Yeah, thank you, sir. So one more question is that can we simulate OFDM or non-orthogonal multiple access or any other multiple access using network simulators?
So using MATLAB, yes, you will be able to simulate the OFDM system.
NS2 tool and all, because can it be like compatible with MATLAB? Or?
No, come again.
NS2 tool, network simulated tool.
Okay.
Is it compatible
So
with MATLAB?
that's again, yeah, another network simulator. So we don't have any plugins using which you will be able to plug. There is no officially supported plugin, but one more base idea is you will be able to simulate or simulate the network using MATLAB itself. So there are various features. For example, 5G again allows us to do a network-based simulation for 5G. So that's again there are various features available in MATLAB itself as a part of the network level, system level simulation and the network level simulation.
Okay, sir. Yeah.
If you are further interested in knowing more about the network level simulation and MATLAB, maybe please feel free to drop me a mail. I'll just give you the pointers.
So last question, this one question which says that can you throw some light on like why there are two different sets of frequencies for 5G communication?
Okay, so that's a very good question. So as we saw earlier, right, FR1 and FR2. So FR1 is something which we have now on the LTE spectrum. So when we want to achieve a very big data rate, and when we want to achieve all those very high bandwidth of operation, so we need a new spectrum, right? We can't fit in all the new use cases into the same available spectrum. So there has to be a new jump in the spectrum space. So that's why the new spectrum is carved out in order to match all these requirements, basically. So because as a consequence of the new spectrum carved out, thanks to all the technological improvements with all the massive MIMO techniques and things, we were able to operate on very high frequency system design. So we'll be able to get a better data rate, and all other use cases which we discussed as a part of 5G can be made enabled.
Okay, sir. Thank you, sir. Uh, Thank you, sir, once again for solving our questions, our queries and answering our questions. So now we shall request few of our participants to kindly provide a valuable feedback with regards to the 5 days STTP. So first we have Professor Srividya K from Sri Venkateshwara College of Engineering, Kannamal, Tamil Nadu, followed by Professor Harish Velinkar from Agnel Institute of Technology and Design, Goa, and followed by Professor Adam Aziz, Assistant Lecturer, Uruk University, College of Engineering, Department of Electronics and Communication, Baghdad, Iraq. So we shall see what these participants have to say about the STTP.
So I am Shri Vidya from Sri Venkateshwara College of Engineering, Sri Permadur. So I have registered and I have been attending the short-term training program on 5G wireless communications using MATLAB and Simulink. So it's a highly novel topic and it's a highly catchy title. So in fact, it bridged the tools and the technologies. So how MATLAB and Simulink, which is normally been applied for signal processing, could be applied for antenna design as well wireless communication. So it was very good. So we are doing research on antenna and wireless side. It is very helpful for us. And we got to know much of information using the eminent resource persons they have invited. All the sessions are highly informative and the schedule is also very, very comfortable. So we could have a good focus on the information that is being conveyed. So the organizers have done a very great job. So they have been very motivating, very supporting, and they have given a lot of assistance. So thank you for organizing such a wonderful event. Best wishes to all. Thank you.
Thank you, ma'am, for your feedback. We move on to the next participant.
Hello everyone, I am Harish Velinkar, Assistant Professor at Agnel Institute of Technology and Design, Asgaon. First of all, I would like to congratulate the entire Department of ETC and Don Bosco College of Engineering for flawlessly organizing this 5-day STTP on 5G wireless communication and antenna design using MATLAB. I feel the entire STTP was in a very good flow, starting right from the basics of MATLAB and Simulink and then going towards the antenna design part. And especially all the resource person and the hands-on sessions held were very good. Also the quiz that was held as a part of the feedback, it was good and it helped us to self-analyze how much you have understood about each of the sessions. So thank you. I would like to thank the principal of Don Bosco College of Engineering, Dr. Neena ma'am, and the HOD of the ETC department, Dr. Varsha ma'am, and our dynamic coordinators for the event, Mohini and Darren, and all those who are involved in organizing this, for holding the STTP in a very flawless manner. And I hope that you all come up with many more such STTPs and FDPs in the future so that we can participate in it. Thank you.
Thank you, Professor Harish. Now we move on to the next participant.
Hello everyone, my name is Adham Rabi Aziz, currently living in the Iraq, Baghdad. I am a researcher in the electronics and communication field, especially the antenna design, such as taper slot antenna, wideband antenna, ultra wideband antenna, reconfigurable antenna, band notch antenna, and so on. I am working now in the Iraq University in the Department of the Electronics and Communication in Baghdad, Iraq. It's my pleasure to be a participate in the 5G and 5G wireless and an antenna design using MATLAB and Simulink workshop. This workshop, it was very useful and informative, especially the 5G content, and that increased our information in this field. Finally, I want to thank everyone who works to make this workshop successful, and I wish to be there another one in the future. And thank you.
Adam Aziz. Feedback, when given well, should not eliminate the receiver of the feedback, but should motivate them to perform better. Yes, indeed, your valuable feedback has and will motivate us to perform better. While organizing this event, we were backed by the head of our ETC department, Dr. Varsha Tulkar, who always motivates us to achieve greater heights for our department and for our college. Now, I request Dr. Varsha Tulkar, Professor and Head of Electronics and Telecommunication Engineering Department and Chair of Women in Engineering Affinity Group of IEEE Bombay Section, to address the gathering.
Good afternoon everyone. So today is the last day of 5 days STTP organized by Student Satellite Club Parikrama, which is an initiative of ETC department. The STTP was technically sponsored by IEEE Bombay Section WI Affinity Group. I am very happy to inform you that we got very good response for all the sessions. Professor Darren, Professor Yashudas and Professor Mohini have really worked hard to make this event a big success. I am grateful to our director, Father Kinley de Cruz, and principal, Dr. Neena Panandikar, for their support. IEEE Bombay Section and Mr. Amit Dhage, Design Tech Systems Private Limited, for being there with us. Our system support staff, Mr. Romeo and Mr. Ignatius, without whom it wouldn't have been possible to organize this STTP. I am also thankful to the participants and the resource persons. I hope this STTP was instrumental in enhancing your skills and knowledge in various domains of engineering and research. Thank you.
Thank you, ma'am. As all good things come to an end, in our life we hardly realize that we receive a great deal more than we give. And it is only with gratitude that life becomes rich. Our hearts too are filled with gratitude towards each one of you for your full cooperation and contribution towards the success of this event. I now would call upon Professor Mohini Naik, coordinator for the workshop, to propose the vote of thanks.
Hello everyone, this is Professor Moini Naik, Assistant Professor at Don Bosco College of Engineering. It's my privilege to propose the vote of thanks for this on this final day of STTP on wireless communication and antenna design using MATLAB and Simulink, organized by Student Satellite Club and IEEE Student Branch, technically sponsored by IEEE WIE section. On the behalf of Student Satellite Club Parikrama and IEEE Student Branch, and the entire ETC department team, I extend a very hearty vote of thanks to all the team members in organizing this STTP. Well, an event like this cannot happen overnight. The wheels start rolling weeks ago. It requires planning and a bird's eyes for details. To begin with, I would like to thank Mr. Suraj Gavande, our speaker, for this wonderful 4 sessions on Introduction to MATLAB and Simulink, hardware interfacing and antenna design using MATLAB. Deep sense of appreciation to our speaker, Mr. Uvaraj Natarajan, for minutely detailing it out 5G wireless communication using MATLAB. Further, we are grateful to Mr. Amit Dhage and Pratap Gavande for their constant support in organizing this event. I express my sincere gratitude towards our management for their unflinching support. Also, our HOD, Dr. Varsha Tulkar, who has played an instrumental role in providing us the technical sponsorship under IEEE Bombay Section WIE Affinity Group. I must mention a profound sense of appreciation to the coordinator alongside me, Professor Darren Rodriguez, for working it out well together. A big thank you to Professor Yeshudas Muthu, IEEE Branch Counselor, for his constant support throughout this STTP. Hearty thanks to our technical support team, Mr. Romeo De Cruz and Mr. Ignatius Dias. Last but not the least, our dear participants who have turned up in such great numbers, not only from India, also from the other countries. Thank you very much for your cooperation. I'm sure you all had an enriching experience learning and exploring new things in MATLAB. Thank you all. Have a great day ahead.
Thank you, Professor Mohi. The end of a story is a new beginning for many others. On this note, let's conclude a remarkable, memorable and knowledgeable training program on 5G wireless communications and antenna design using MATLAB and Simulink. On behalf of Don Bosco College of Engineering, we sincerely promise you that we will keep on organizing such events with some more innovative ideas to nourish your mind and fill you with more knowledge. One such event is an ISTE-approved 1-week online faculty development program on recent advances in RF and microelectronics, which will be organized in collaboration with NIT Goa from 31st August to 4th September 2020. The link for the registration is already in the chat box. Interested participants can register on the link which is given. Thank you very much. Before I sign off, we wish you all a very fruitful and productive day. Thank you once again for joining us today and all these days of the workshop. God bless you.